Imagine processing millions of events per second and suddenly your Kafka broker crashes. Does your data disappear or does Kafka recover automatically? Hello everyone, Suhail this side. Welcome back to our channel. So in distributed systems, failures are not rare. They are expected. And systems like Kafka are designed with this assumption from the very beginning. In this video, we will deep dive into Kafka fault tolerance and understand how Kafka ensure your data is safe even when brokers fail. We will explore replication, leaders and followers, ISR, leader election, and see ourselves how Kafka automatically recovers from failures without losing data. So let's get started. In the last video, we have made the 3-node Kafka cluster setup and we went into a great depth. So let's make our 3-node Kafka cluster up and running first. So what I will be doing is I will be going into the folder where my Docker Compose file is present. So let's go there, and if you see, I am into a folder where my Docker Compose file is there, right? And this Docker Compose we have already seen in the last video, right? So this was the Docker Compose file, and in this Compose file we are just spinning up the 3 containers, the Kafka 1, Kafka 2 and Kafka 3. So let's run this file quickly. Docker compose up -d to start the process in the background. So let's do that, and if you see the docker ps-a, all the Kafka containers are up and running, right? And this is a brand new cluster, right? So let's go into one of the containers. Let's go into the Kafka 1, right? So you can go into any of the container whatever you like, but for simplicity I'm just going into the Kafka 1 container, right? And if I do the bash, I can directly see what all topics are there, right? So how we can do that? Kafka topics, and then here we need to pass the bootstrap server, right? Now in the last video we have discussed what port and what IPs are being used for which purpose. So if you recall that, so we have seen this Docker Compose file and also this ports, right? So if you see, the advertised listeners is the configuration which is used for clients. So the external is something which are being used for external clients, and internal is for something which can be used internally, right? So where we are running the commands as of now, it is internal to the Kafka cluster, right? So here we can easily use this port, the 9092. So what we can do is I can just pass the Kafka 1, right, 9092, and since we can pass multiple nodes this time because we have the 3-node Kafka cluster setup, so we can do that. So Kafka 2, then 9092. So if I do the listing of the topics, right, so I can see there is no topic present, right? So what I can do is I can quickly create one topic, the order events topic, which we were being discussing in the whole series. So let's create that quickly, right? So what is the command? We just need to pass the topic, and then we can pass the order events, and then we can pass the partitions. We can use the partitions too, right? And then we can pass the replication factor as 3. Till now we were using the single node Kafka setup and we were not using the replication factor because it doesn't make any sense. Now since we are running the multiple servers, we can also specify the replication factor. So here replication factor 3 means I want 3 copies of the data whatever is being published onto the Kafka. So it simply means that. So I can just do the create. So if you see, the topic has been created, right? Now I can describe this topic as well. So let me do that part quickly. So if you see, there are 2 partitions because we have specified the partitions as 2. So the partition 0 and the partition 1, right? And for partition 0, the leader is node ID 3. So if you see 3 and 1, these are the node IDs, and from where it has picked these node IDs, we have already mentioned in our Docker files. So if you see, we have the different server properties. For Kafka container 1, we have the node ID as 1. For Kafka container 2, we have the node ID as 2. And for Kafka container 3, we have the node ID as 3. So that's where we have mentioned these node IDs, and it has been picked from that configuration, right? So we have specified the replication factor as 3. So that is what the replicas means. So how many replicas we have? The replicas as 3, 1 and 2. Again, 3 is the node ID, 1 is the node ID and 2 is the node ID. Now what is ISR? This is something very new which we have not discussed yet. So ISR means in sync replica. That is whatever data I have onto the leader, that is on node 3 for partition 0, the same data is available on all these replicas. So in this case everything is in sync. So similar for partitions 1, the whatever the data we have on node 1, because it's a leader, all those data has to be available on this nodes 1, 2 and 3. So since we have just created the topic right now, so everything is in sync. Now what I will be doing is I will be opening the new terminal. So if you see for partition 0, the leader is node ID 3. Now let me stop the node 3, right? So I can just stop Kafka 3 and let's see what happens. So if I do that, and now this time let's describe one more time what happens internally in the Kafka. So this is the thing whatever has happened. So if you see now the topic order events, the partition 0 the leader is 1, and similar for partition 1 the leader was already 1. So if you see there was the leader for partition 1, and for partition earlier the leader was 3. Now when we stop the Kafka container 3, what happens is it has rebalancing has happened, and what has happened is the partition 0 the leader node ID is changed. Now if you see the in sync replicas, right? So in sync replicas are 1 and 2 because the node ID 3 is down at this moment, so it is not in sync. So even though we publish anything on partition 0, those won't get sync into the node ID 3, right? So that is what it has depicted. Now let me bring up the Kafka container 3, docker start Kafka 3. Now again all my containers up and running, and let me do again the describe. So if you see the leader has not changed, but if you notice the in sync replicas, again for both the partitions the in sync replicas are all the same, 1, 2 and 3. Now all these replicas are in sync. Now what I can do is, if you see for both the partitions the leader node is 3, now leader node is 1, sorry, right? Now what I can do is I can stop this Kafka 1 and see the behavior. Let me stop it, and now I got exited out of this container because I was into the Kafka 1 container only. Now let me go into the different container. Let's go into the Kafka 3 and see what happens, right? So if you see docker, let me do the Kafka topics again, cd Kafka bin, and let me do the Kafka topics as such. Let me copy this command, the complete command, and if I do the describe again, so if you see now the partition is changed, right? The Kafka, it's a warning log that the Kafka 1 container is no more available, right? The DNS resolution got failed for that, that is okay. But if you see this describe information for both the partitions, now the for partition 0 the leader 3 is node, and for partition 1 the leader is node ID 2. And if you notice the in sync replicas, those are also changed. So the in sync replicas for partition 0 is node ID 2 and 3, and similar for partition 1 the in sync replicas are node ID 2 and 3. Now let's see the practical demonstration, where what we would be doing is we would be publishing the messages from the Java application, right? And we would be consuming the messages from the Java application, and in between that process we would be stopping the Kafka servers, the Kafka brokers, and see what data we are receiving. Is the data getting lost anywhere? So that is the behavior we would be going to notice next. Now for that demonstration I would be using the partition as one only, the single partition, so that I can just show you the messages in sequence. So for this what I will doing is I will be just deleting the topic. So let me first of all bring up this Kafka 1 container as well, right? and what I will be doing is I will be deleting this topic. So let's do the listing and see if there is any topic available. So there is no topic available. Now I will be creating the same topic but with single partition. So for replicas would be 3. The 3 would be the replication factor, and in sync replicas would also be 3. But partition, why I am creating only one partition? Because I just want to show you the messages in sequence so that you can see really the messages are not getting lost. That is the main purpose, right? So if you see, we have changed this command to pass the partitions as 1 and the replication factor still considered to be as 3. Just the same way, I want 3 copies of the data whatever is being published onto the Kafka broker. So let's create this topic and see the describe information. What is the information, right? So if you see, for there is a single partition, the partition 0, and the leader is node ID 2, and the replicas is again all the 3 nodes, the 1, 2 and 3, and also the in sync replicas are 1, 2 and 3 nodes. Now we have created the topic. Now let's go back to the IntelliJ and start the producer and the consumer. Now what I will be doing is I will be creating the new package, the day04. The same thing what I will be doing is I will be just copying the file from day02 package, right? And I'll be just pasting over here. I'll just change this name, the rename, and I will just use the day04. So I have copied the code from day02 package, the consumer and the producer, and copied this code into the new package, the day04, and refactor the class names. The day04 is the Kafka producer for this video, and day04 Kafka consumer is for this video. Now what I will be doing is I just need to make the few changes. First of all, if you see the Docker compose file, right? So what we are using for our Kafka nodes connecting to the Kafka cluster. So we are using the port as 8081, 8082 and 8083, right? So we are using these ports. So what I will be doing is I will be doing the same. Let me use 8081, right? So you can specify this as also like this 8081, then you can specify 8082, right? And you can pass 8083. The same thing means since we have the multiple bootstrap servers, you can pass all those server IPs over here, right? And the similar thing you can use in the Kafka producer as well, right? Yeah, that is the only change which we supposed to do. The bootstrap servers change and rest of the things should be working. In the producer code, I will be doing one more change. So in this code, if you see, we were publishing the messages, just the 100 messages we were publishing, right? But let's say we want to publish 10,000 messages because we want to see the real behavior, what is happening, right? As and when we are bringing down the Kafka node. Now let me start the consumer first, right? So the consumer has started, and now let me start the producer. So before starting the producer, let's see the logs for the consumer application. So if you see, these are the logs for consumer, right? And if I show you the leader, whatever has been assigned to this consumer, so if you see, the leader is node ID 2, right? So localhost 8082 is the leader node, the ID S2, right? So the leader and epoch, current leader, right? So with this, you would be seeing that the node ID 2 is the leader. So even if I show you from the console, right? So for partition 0, the leader node was node ID 2, right? So the same thing has been printed onto these logs as well. Now let me start the producer and see how consumer is receiving the messages. And now I have started the producer. If you see, the consumer started getting the messages, right? The order ID 0, 1, 2, 3, 100, right? Now what I'll be doing is I will be stopping leader node, that is the node ID 2. So let's do that quickly. Docker stop Kafka 2. So let's see the logs, and if you see the logs, so there is a kind of network exception. That is, these are the consumer logs, right? In the consumer logs, it has received this event that the node ID2 is disconnected, right? And with this, what has happened is the leader was node ID 2 earlier. Now once this has happened, the Kafka internally elects the new leader, right? And the consumer started consuming the applications accordingly, right? So if you see the messages, the order is still same. The 273 was the data which was before node ID 2 disconnected, and even after that we can consume the same data. So the similar thing you can see in this producer application, right? So let me show you. So the producer application was producing the messages. So when it has produced till message ID 273, and after that the node ID 2 disconnected, because it was writing where? It was writing to the leader node 2, and the same has been getting passed to the replicas. Even if you see over here the replicas, right? And I will just show you, right? So the replicas is 3 and 1 right now, the in sync replicas, right? And the leader has been changed. Now the leader node is 3. So if you see, the messages are getting processed and the consumer is also processing the messages. We have seen who is the leader. The leader is node ID 3. Now let me stop the node ID 3 as well and see the behavior, how things are happening behind the scenes, right? So Docker stop Kafka 3, right? Let's do that. And if you see the consumer logs, the application is still working, right? So if you see in the consumer logs, the node ID 3 is disconnected, right? This was the leader. And even the producer, if you see the producer logs, the node ID 3 disconnected, but still it keeps working because the node 2 is still, the node 1 is still up and running, right? So if you see docker ps-a, we have only one container up and running, that is the Kafka container 1, but we have already intentionally broke down the two containers, but our Java application is still working fine, still consuming and producing the messages in order. Even after the node ID 3 disconnected, it receives the messages in sequence, and also the publisher publishes the messages in sequence. Let me show you the logs, right? So the node ID 3 disconnected, but if you see, the message is still producing the same, right? So the producer and the consumer applications are still working fine. Now you would argue that let's bring down this Kafka node 1 as well, but that's a big problem. It simply means your entire cluster is down. In real time or in real world, it should not happen. Even if it is happening, if your entire Kafka cluster is down, then in that case, the client has to store those messages into their storage and it can be sent later for processing. So that's how things works in real world. That's all for the day, and that's how Kafka achieves fault tolerance and keep your data safe even when brokers fail. So if you are serious about learning Kafka and distributed systems, so this channel is for you. Make sure to subscribe because we will be going much deeper into Kafka internals, real world architectures and production grade system design. Thanks for watching. I'll see you in the next video.